Hello, full stack. 1706 remote cohort, New York. This is my tech talk, not yours. I'm Shane. The solution only eludes you if you don't look for the answer. I have a problem. Reggie is the best. I want to see what he is doing when I'm not at home. Because look at this guy. Come on, look at him. Oh my God. So I've tried a webcam. It only worked when he was in one room. My wife thought I was creepy. What if I could build a robot that would go where he goes? I could do this. I know I can. Oh, Google, what should I do? Tesla. Tesla. Tesla is what Google said I should do. The object here, of course, is, and it's always a constant, robots are fun. What is Tesla? What is this thing, Tesla? The basic idea behind Tesla is an internet of connected things, so devices, hardware, connected, where you set loose web developers on that hardware world. A lot of this stuff happening during the founding time of Tesla during 2013. They started in 2013 with Silicon Valley dreams. By 2016, they became a JS Foundation, which means nobody works for poor old Tesla, and they all work on the weekends for free because they love robots, just like me. Tesla 2 came out to market as their second product. So Tesla 2 came out to market in early 2016. So that's a good thing for all of us because that's what I'm going to be talking about. I'm getting really excited. So let's get into this. This is the hardware. This is the little board. This is our baby robot just waiting to come out. It has 2 regular USB ports and 1 mini USB port. It has an Ethernet port, not the fastest one on the planet, but still available. It has Wi-Fi. Oh, look at this. It has a router on a chip. That's not a dip chip. That's just a small baby router sitting on a chip. It has a coprocessor. No, it's not 2 processors hanging out. It's a small baby processor for our baby robot that still is yet to come out. It has 64 megabytes of random access memory and 32 megabytes of flash memory. Not a lot of storage, but enough to get the job done. So here's where the magic comes. This is where we are now going to start connecting things. It has 2 ports with 10 pins in each with 3 pins on the deck. These pins, we're going to talk a lot about them. 2 of them on the base 10-pin side little doohickeys there are 3.3 volts with 2 ground. And here's where the magic starts coming in. We have 16 digital on and off, power, yes, no. And then we have 10 analog in. So those 16 digital also have a side job as being, 10 of them at least, can listen in on analog and deliver out an analog. What's analog mean versus digital? Analog is variable, okay? So from 0 to 3.3 volts. So the power, if it was like 1.3 volts, or turn it down, turn it up, kind of like a dimmer switch. 8 interrupts, right? 8 interrupts. So also those 10 to 16, there's 8 of them that can listen to changes. So think of event listeners, okay? Think of event listeners. Yeah, I know what those are. Those are in JavaScript. And then there are serial communication, stuff that's a little bit over my pay grade, but think about streaming 1 bit at a time in a asynchronous and synchronous fashion, things that can make motors happen or what have you. Pulse width modulation, fancy for a digital signal that can help with managing a red, green, blue light, or a servo motor, which we'll talk about a little bit, which is in essence like an elbow joint, if you will, on a robot. Digital analog conversion, and a 5-volt pin so you can power motors. That sounds exciting. I'm excited. I'm getting fired up because I love robots. Data, Android, but also a robot. Maybe the most famous robots on the face of the earth. They call themselves droids, but you know what? Robots. And then there's this guy. That guy. He's in some 70s TV show, 60s TV show, lost in space. Sometimes an evil robot. Danger, danger. All right, so what's this all mean to me? Well, I will tell you what this means. Script. What if you could use Node to talk to this device? What if you could create a directory, you init it, you have this command line interface for the T2, that's the CLI is, you put that in, install that, you initialize, and then you have these TESL first-party modules that exist where you can hook a camera up. You can create a web server. That's right, this little thing that has the chip and the router, you can create a web server. You can check your GPS and have it report back to you. The device itself, a servo, you can manage a servo motor like I was talking about earlier. You can have audio in or audio out. You can have an access point. So these could be networked together if you wanted to get really crazy. And that's what I'm about. And then it can tweet. But looking at all these things, it looks like this would actually make a better president because it only tweets when you tell it to. And, oh, good. Nice for you to slow the machine down. Okay, so this is all about JavaScript. So what does this mean? I'm gonna bring in this TESL module. I'm gonna think about the digital inputs and outputs and analog inputs and outputs. And we're gonna build something. But don't worry, it's just objects, arrays, strings, and it returns fun. There are about 20 modules that make up TESL. So this is the thing that really got me fired up when I really started digging into the thing is, I bring in TESL, and all of a sudden, all this stuff is on my computer, and I start looking through it. And I'm thinking to myself, in the JavaScript world that we live in today, all of these really cool things that are being built on basis of other people's stuff, meaning base 64 and base 32, which helps you convert our JavaScript code to communicate with the hardware in the binary form. How fun is that? I would never do that. I wouldn't even think to do that. All right, so let's do a little hello world. We're going to be using digital pins here to talk about the hello world of the world that is called hardware, turning on and off some lights. On the right, we require in the module, we have a method that runs every 1/10 of a second. We run it, it counts through the pins, and in this case, I have pins 0 through 3 running through in a toggle on and off. This is all within the method. The toggle is saying, I'm on, I'm off, I'm on, I'm off. In the circuit that's to the left of you, this is what these are called. We have the TESL board to the right. We have the breadboard, which is the basis for where we connect everything. We have the colored wires, which are taking the digital signal over, and then it's going to hit these resistors that are in the center there, the little black and orangey thingies that are in the middle. We have a ground sitting on the back half of all these LED lights, and the resistor is connecting into the front half, or the power side, the positive charge of this. And look at this. We got, what? I made that. How exciting. I know you're excited, but you weren't as excited as I was when it went down. All right, here's an interrupt, okay? Here we have up on the top left is our circuit, and it's listening to a change, and the change happens to be these two magnetic strips that are being pulled apart, just like if you had like the doorbell of a grocery store. You open it, it goes ding, ding, ding. It's exactly the kind of thing that it is. And on the right here, we're looking at pin A2 and pin A5. Pin A5 is writing off the pin so that it's powered off. The default is to power on these pins. It runs through. A2 is listening for the change. It's the interrupt. It listens for the change. That change happens, and then it toggles pin A5. And what type of magic happens? Off, I'm on, and then off. Lights changed. I'm winning right now. I love this stuff. Are you guys excited? I hope so. There's even more. And now we're going to start talking about Johnny Five, who has been working on this for a little bit longer in terms of bringing different boards that are out there. There are more boards than just TESL, but Johnny Five has kind of jumped on the TESL bandwagon in terms of having this SparkFun kit, the inventor's kit that I have. And they have also created modules, Johnny Five, TESL.io, and so that they can create something. So let's talk about analog. Let's build something with some analog stuff. We're going to read a potentiometer. You don't know what that is, do you? I didn't either. It's a knob. Fun. Okay, we're going to change based on this script that's on to the right here, you can see the circuit below, we're going to turn this little blue doohickey knob, potentiometer, say that 5 times fast, and we are going to take this pin A7, listening. We're going to do a change with that sensor. As it's listening, it's making that change. And then we're going to scale the sensor that is also wrapped back around through the other pin. And what happens? What happens? Look at that. That's with JavaScript, guys. That's JavaScript working with all the modules that are already invented and already out there. I cannot believe it. Light sensor. This is fun. So having a sensor that can see a light change, still JavaScript up in the upper right. I'm not writing binary, nothing. I have my little baby robot just waiting to be something important. And we have the light shift. It looks in this sensor through the circuits and the resistors that are in there are going to watch for the level of light in an analog input off to turn down below that level. What? No. Yeah. It's a good thing I recorded these things because sometimes it doesn't work that way. I'm just kidding. That's a joke. Uh-oh, motors controls. Now we're getting really funky. Below this circuit here is for 2 motors and a whole bunch of stuff. The code above it is for 1 motor. And what happens in this is we have the board, which is brought in by the Tessel IO. We build it. 5 sets it up. They work together. They're pals. We're ready. You can see that the motor is, when it's a single motor, is on 3 pins. So we talked about that a little earlier with how the different things interact together in the whatever it was, synchronicity stuff. And we stop, forward, and reverse, this one. Now, what you're about to see is a motor that has forward, so 2 motors, that's what the circuit is. So I made the big circuit because I wanted to have all the wheels going. And we have the ability to slow it down based on the potentiometer that you saw earlier. So we can turn it in directions. We can switch it, which I didn't show you the example of the switch, but end all be all reality is they're going forward, they're going backward. And this is starting to just freak me out how much fun this is. All right, here we go. See, robots are fun, and the Regibot is in progress. Motors run, you can have directional variable speed, a camera attached. The Express, I have an Express router running on this thing. It is now set to Dwight.local.888. Dwight is the name of it. And the camera streams to the web. We find Reggie, there he is. The next things that I'm going to do with this thing, hopefully, are I'm going to put it on the web. I'm going to be able to have buttons that control instead of switches. And then I'm going to mount with the wheels and VPN into the house and find out how long it takes Reggie to destroy this thing. So that's my plan. Here is more stuff about Tessel, where you can find information, where you can participate in fun. I hope you do it because I think it's a really cool thing to be able to take and make objects that are in the tangible 3D world move and react to our 2-dimensional faces that we see every single day. That is the end of my tech talk.